Om Sri Sai Ram. Hearty welcome to Sri Sathya Loka Seva Gurukulam. I think all of you are ready, fresh. So take your books and pens and get ready for a new chapter called Magnetic Effect of Electric Current. Before we commence with the chapter, let us see what are the things you know that is called as previous knowledge. Of course, some of you are very expert or knowledgeable. You know what is the importance of electricity. In the previous chapter, you have heard what is electricity. It is a form of energy, convenient form of energy, used in almost all activities of our daily life. Is it not? The light what you see, the fan what we gives air, and ovens, iron box, heaters, boilers, big list will be there. They are all products of electricity. It's a very convenient form of energy. It can be transferable, and you can make different forms of electricity. And about magnets, I think so many have you seen magnets, especially bar magnet. The repelling of when the opposite poles come near, they attract. Like poles come near, they repel. So magnetic property you have heard about, and also you might have done some experiments with magnets. And they have got what are called as poles, of course, about which you will study a little later. And also you have studied about the relation between electricity and magnetism. Electricity and magnetism, they are interrelated. Wherever there is flow of electricity, there will be magnetic property. Similarly, when a magnet is made to move in an electric coil, there will be current will be produced. So there is interrelation that you can see in the construction of dynamos, motors, and so on. Okay, these are all the knowledge you have already. And also you have heard that there is a field around a magnet. How do you know it? If we sprinkle some iron filings, a magnet will attract. Is it not? There will be an area. And even in a magnetic needle also shows the presence of the magnetic field. And also you know that there are lines of force. When there is a force, there will be direction. It is a vector quantity which has got both magnitude and direction. So these are some of the things which I already studied. And also the circuits and precautions to be taken while using electric energy. How to on this switch, how to off it, how to use the heater, boilers, cooking items, and so on. Should take proper care. There will be what is called a short circuit sometimes. Is it not? And also how the circuits are made. You know how the wires are connected to the different appliances. All these things you already know some of the things. Now we will see some more details about it after knowing this basic. And let me just start with a story. You are interested in stories, right? No, it happened in Asia Minor. There was a shepherd. You heard about shepherd? What do they do? They look after the sheep. And the shepherd had a stick in his hand. And it happened in a place called Magnesia. The area where he was making the sheep to graze is Magnesia. And he had a stick, a long stick, the bottom of which had a iron frame, or you can say iron basement for the stick. So he was just moving, and when he was just moving on a rock, his stick caught hold. Something held his stick. He cannot lift it so easily. He was surprised. In those days, people used to believe in ghost spirits and all. He thought some spirit is there inside. Somehow he lifted it with all difficulty. Again, when he put again to that rock, there was some other pulling. So his stick went on, got pulled by some unseen force. He was very interested, and he spread the message to others. Then they took the piece of stone from there, and that was done with some experiments, and hence the magnet was discovered, and the name magnet came because of the area called magnesia, means a substance that which attracts. So in today's class we will see the magnetic effect of electric current. In that we will start with the basic of magnet. Magnet has always been a thing of awe and attraction. It is a wonder. How does it happen? Of course, in nature and earth, you find lot of wonders. So many wonders are there. This is also one of the wonders. According to history, the use of magnets was discovered by the ancient Greeks during the period of Greek civilization. Greek civilization is one of the ancient civilization, just like India. Roman, Greek, Indian, and to some extent Babylonian. They are the very ancient civilizations. They found stones which were able to attract iron and nickel. They are called as magnetic substances. The substance that attracts magnets are called magnetic substances. So they call it as lodestones. And the formula is iron oxide Fe3O4. Iron oxide. The property of attraction on small particles of iron towards lodestone is called magnetism. Okay. So this is a very special property. Just as you have gravitation is an unseen force, but it pulls each and every object, is it not? So also a magnet also, and this is what is called as lodestone, and it attracts substances like nickel, cobalt, etc. Now we must know what is meant by a magnet. Magnet is a material or object that produces magnetic field, which is responsible for a force that pulls or attracts other materials. So, it is a material that attracts substances like nickel, cobalt, etc. Okay. So, these are some of the different kinds of magnets. Most of you might have seen it. These are called circular magnets, and these are called bar magnet. It is like a bar. It is a circle in nature. And this cylindrical magnet. You have rectangular magnets, and it is a horseshoe magnet. Why it is called like that? You have seen horses, right? And below their legs you have got this type of that's why it is called as horseshoe magnet. So these are some of the different kinds of magnets, and also you have a magnetic needle, magnetic compass, etc., etc. So the magnets that are commonly available in different shapes: bar magnet, this is bar magnet, just like a rectangular bar; horseshoe magnet, like the horseshoe; and then cylindrical magnet, Then you have circular magnet, rectangular magnet, and so on. So these are different kinds of magnets. And I need not tell about uses of magnets. So many uses are there. In tape recorder, you have seen tape recorder? So this is the tape recorder. Tape recorder will be of this type, and this is radio, then motor, then doorbells, or you call as calling bell, headphones, etc. All of them, in that there will be use of magnet. In this case you have got an electromagnet. Okay, and in this case also there is a bell, and in that bell you have a electromagnet. So like that the list is very big. Coming to properties of magnet, it attracts magnetic substances like iron, nickel, etc. towards itself. Second property, a freely suspended magnet always comes to rest in the north-south direction. Like poles repel each other, while unlike poles attract each other. And iron pieces are brought near a strong magnet, they also start behaving as magnet. So even a small thing brought near the magnet becomes like a magnet, of course temporarily. And let us see some experiments or activities in connection with these properties. And also one more property, the poles of a magnet, there are two poles, namely north and south pole, cannot be separated. Suppose you break a magnet, what happens? It breaks up into two. Those two pieces also act like a magnet. Still you break. Still also the continues. Every small even atom, it has been found that it acts like a magnet where there is attraction and also repulsion. When you get repulsion, when you have like poles. When you get attraction, when you have got unlike poles. Okay. So these are some of the properties, and we shall see some activities now. And the first activity is, for materials required are magnetic needle, 2 bar magnets, some iron filings, and an alpin. And first step is that a bar magnet is taken and tied with a string to be hanged with the help of a hook. The bar magnet, so this is what is called as a bar magnet, tied with a string, and it is attached to a hook. What happens? If you rotate it any number of times, it comes to rest in north and south direction. How do you know? That can be seen by what is called as magnetic needle. So this is a magnetic needle which shows that a magnet comes to rest in north-south direction. And some iron filings are taken near the bar magnet, they stick to the magnet. This magnet attracts iron filings. We can observe that the amount of iron filings near the poles is maximum. So near the poles it is maximum, and in other places it cannot attract. So this is a bar magnet. If you bring some iron filings, they will stick on like this. So beautiful. See how nature is so beautiful. See the construction. Automatically it does. We find near the poles more iron filings, and from north pole goes away to south pole, they come near. These are called lines of forces. And in the middle you find very less lines of force, which are very less. Okay. So this is one more activity with regard to the properties. Coming to third activity, if you bring any pole of a bar magnet near the pole of a freshly suspended bar magnet, what happens? then either it will attract or repel the same. Opposite poles of a magnet attract each other, while like poles repel each other. See, what do you mean opposite poles? If one is south, another is north, there will be attraction. They are called opposite poles. Whereas if you have the same poles, north, north, see here, north, north, repel, north, south, attract. Similarly, south, north also attracts. Similarly, south, south repels. So, in short, we can say, like poles repel each other. This is repulsion. Going away. Very beautiful. You can also try taking two bar magnet to see how it is repelling. And if it is opposite poles, there will be attraction. Okay. These are some of the properties of magnet. And one more thing, one more activity, an iron alpin, this is called alpin, brought near a magnet and left there for some time. We find that alpin also has required magnetic properties, and iron filings start sticking to the ends of the alpin as well. So bring a pin, and if you bring near the poles of a magnet, for temporarily that pin also acts like a magnet. And one interesting thing is, if you attach one more pin, that also attacks. One more pin, that also attaches. Some 2-3 pins, they get attracted, and that is what is called induced magnetism. So, because this is a magnetic substance brought near a magnet. When a magnetic substance brought near a magnet, it acquires magnetism temporarily. This property is called as induced magnetization. Okay. So, these are some of the activities, and one more is the bar magnet is to be broken into small pieces. We observe that each piece acts as a bar magnet only, and the two poles are compulsory to be there. Suppose you break this bar magnet into two. Here these two also acts as a magnet. Again they break them into two, NS, NS, NS. Anyway, every small piece of magnet act like a magnet. That is another special property of magnets. Now, why does it do so? Let us see. That is because of a field around a magnet, that is called as magnetic field. So, when a magnetic needle is kept near a bar magnet, the magnetic needle rotates and stops in a particular direction. This shows that a force acts on the magnetic needle, and that makes it rotate and rest in a particular direction only. This force is called torque. So, suppose this is a magnet. You bring a magnetic substance near it. It also gets attracted, and temporarily it acts like a magnet. And this force is called as torque, T-O-R-Q-E. So, this property of attraction or repulsion, of course, if it is a magnetic substance, it is only attraction. If it is another magnet, there may be repulsion also. That is because of magnetic field. Field means what? The area around a magnet. Even divine personalities you might have heard about. Divine personalities like Baba or so many great people, they also have got a attraction power. Sometimes they do miracles, or at least smile. Their smile itself will attract others. Their love, the peace, the joy, what they give to others, that attracts. So people are attracted to it. So what is a magnetic field? The region around the magnet where the force on the magnetic needle occurs and needle stops at a specific direction is called magnetic field. So the direction of magnetic field is represented by magnetic lines of force. And all of this you have already studied in class 7th and class 6th also. So only some more details about that. So this is a bar magnet, and these are called lines of force, and this area is called as magnetic field, and this is what happens in case of iron filings. And you find a lot of lines of force around the poles, and this is a experimental observation. Of course, in higher class you have to do experiment on this also, taking a drawing sheet, fix it to your drawing board, keep a bar magnet in the middle, and then just by taking a magnetic needle, it go on drawing the lines of force. That's how you get it. These are called lines of force. It starts with North Pole, end with South Pole. They do not intersect each other. They are more denser in the poles. And these very interesting experiments. And that will be what is called as null points, about which you study later, okay? And in the case of, there are two cases here, when they will show different type of lines of force. And about the properties, the first property, magnetic lines of force always start from North Pole. They start from North Pole, end at South Pole. So start from North Pole, end at South. So the putting of arrow mark is very, very important, because it's a vector quantity. It has got both magnitude and direction. How do you measure it? By a unit called Oersted, because it was Oersted who found out or measured this. So these lines of force never intersect each other. They do not intersect. Each has got its own area. And magnetic field is stronger at the poles compared to the other parts. So it is stronger here. And one important point you must note, when you say magnet is suspended with a thread, it always comes to north-south direction. Question will arise, why? Not east and west, always north and south. The reason is, our earth itself is taken as a huge magnet. How does this earth get the magnetism? That is because of the metals like iron and nickel being present inside the earth. Our earth itself acts as a giant magnet, not ordinary. Giant magnet. That is what happened to the shepherd. With the south magnetic pole somewhere in the Arctic, north magnetic pole in the Antarctic. So in the geographic, this is called north of the geographic north, this is called geographic south, and this is a huge, we say globe, earth as a globe, okay? Here this is called geographic north. This magnetic south is near the geographic north, and magnetic north is near the geographic south. That's why a freely suspended magnet always comes to rest in the north-south direction. It is because the hot liquid in the center core contains iron, and as it moves, it creates an electric current that causes a magnetic field around the earth. So in the center of the earth, inside, there will be metals like iron, and that produces waves, electric waves, and that electric waves will be converted into magnetic field around the earth. That's why always magnet show north-south direction, but not east-west. Okay? So in brief, you can say whole earth is a huge magnet, and that's why all the magnetic substances are attracted by the earth, just as you have gravitational pole. So the poles are not the same with the geographic north and south poles on a map tilted at an angle of 11.3. So there will be tilting. So this is north and south of the earth. So this magnetic north and south is at an angle of 11.3 degrees, tilted, but they are not same. Due to this, if a magnetic needle is suspended freely, it rests north and south direction, and it is useful in navigation. What is navigation? You might have heard about ships and submarines and so on, right? So when they go on ship now, everywhere water. And what makes the ship to come to the shores? That is because of a magnetic compass, what you call mariners compass. So these mariners compass will always show the direction of the ship. That is why the word mariners. Otherwise they will not be knowing. For example, if a ship starts from Mumbai, they want to go to Dubai. Where is Dubai? Dubai is in the western direction. Is it not? And suppose there is no direction shown, what happens? It may come down to Cochin or Kerala, which is in the southern direction. So to know that to go to Dubai, they should go in the eastern direction. West coast, it goes toward that direction. So you should know by the help of what is called as mariner's compass. That shows the direction of the ship and submarines also. And anyway, it is one of the interesting forces that are present in the earth. Now let us see what happens when a current carrying wire. How about the magnetic field around the current carrying wire? So think of the wire having current, and what will be the nature of the magnetic field? It was H.C. Oersted, on his name only the unit is named now, Oersteds. In 1820, a scientist from Denmark, how are they called? Danish. H.C. Oersted observed the effect of magnetic field when there is a flow of electric current through a conducting wire. This experiment is called Oersted's experiment. This principle of magnetic effect of electric current is used in many appliances like a motor. Means what? Wherever there is a electricity, there will be a magnetic field around it. Whenever there is a magnet, there will be electrical energy around it, or you can get it. So that is all the basic things here must note. Or in short, electricity and magnetism are interrelated. And this has been shown experimentally by Oersted. And what is the experiment he did? He took a piece of copper wire. So conducting wire, especially copper. Why you only take copper? Any conducting wire okay. Aluminum also okay. Copper also okay. Silver is very good. Platinum is still good. Any conducting wire, usually copper is taken and then attached to the two ends of a battery with the help of a connecting wires. So that is connected to a battery with the help of wires. Okay. A magnetic needle is kept. This is called a magnetic needle. And what does it do? Kept parallel to the conducting wire as shown in the figure. So it is kept parallel to this. And what do you observe? When the circuit is completed, the magnetic needle shows deflection. So here, before passing current, there will be no deflection. Only when you start flowing current, there will be deflection. So that is what observation. So there are 4 observations here. If the current is increased, there is greater amount of deflection. Suppose 6 volt is there, it shows on deflection. Suppose make it 8 volts, then will be more deflection. Or if you reduce it, 4 volts, the deflection will be less. So that is the meaning. If the direction of flow of electric current is changed by reversing the end of the battery, the direction of deflection in the magnetic needle is also reversed. Suppose we change direction of current, means plus to be minus, minus to be plus. Then also you see that very beautiful experiment. You can see the deflection also in reverse order. Thirdly, the current flow, if the current flow is stopped, means if you stop the flow of current, what happens? Deflection. The deflection in the magnetic needle also ceases, means stops. So only when current is there you can find the deflection. Means what? There is a relation between electricity and magnetism. So conclusion what you can give? The magnetic field is an effect of the flow of electric current through the conducting wire. Wire should be conducting. Okay. Now coming to the home assignment. First question, what happens to the properties of magnet when it is broken into pieces? Do magnetic field exist throughout the space? Third question, name the part of telephone where magnet is used. Fourth, list the properties of magnetic lines of force. Fifth, what are magnetic poles? Okay, come prepared. Wish you all best of luck. Thank you.